Hello, React Native developers. Imagine having to follow William. That was really cool. So here we go. Last year's App.js was my first conference talk ever, and it was so much fun. It's great to be back here. That talk was about Legend List, which was version 1.0.14 at the time. Since then, there's been almost 1,400 commits, and it has over 1 million downloads per month now, which is crazy. Since then, it now supports both React Native and React DOM, so it's now the fastest list library on both mobile and web. It's been super optimized for chat apps, and even has this cool anchoring feature that can scroll user messages to the top built in. And now it's on version 3 beta 56. It's even faster than V2. It's more stable. Initial scroll is finally perfect. That was the hardest thing. It supports animated item transition, tons of bugs or fixes. I'm really excited about it, but it's just too many betas. So today I'm changing that. It's 3.0 stable. But that's actually not what I'm here to talk about today. I'm here to talk about performance. My plan for this talk was to cover a bunch of different performance topics, but as I benchmarked them and helped a few companies optimize their apps, I realized that one of these is so much more impactful than everything else, and most apps are doing it the slow way without even knowing it. So we're not doing that at all. Today we're talking about completely rethinking app architecture. I want to talk about making apps that are really fast. Not just fast for a React Native app, better than native. I worked with Fernando Rojo on animations and list performance for Vercel's V0 iOS app. It's a beautiful AI chat app that just feels incredible to use. When it was announced, people couldn't believe it was React Native because it felt so good. And here's a React Native Mac app I'm working on. This video is me double-clicking the app, and it's fully open and ready instantly. It opens a 10 megabyte markdown file in 20 milliseconds. Let's look at that in slow motion at 5% speed to see how crazy this is. It's actually already fully open, parsed, and rendering rich content before the window is finished opening. For comparison, here's Zed, which is a text editor built in Rust, known for being very fast. It opens the file quickly, but it takes over 4 seconds to parse and syntax highlight. Most other apps I tried either refused to open it, froze, or crashed. So 20 milliseconds is crazy. Here's another app I'm making. It's a React Native Mac MP3 player. It uses less CPU and memory than almost every other music app I tried, even the native Apple Music. These are React Native apps, and they're faster than almost every other app on my computer. They're not just fast relative to Electron WebView apps, they're faster than most native apps. Because React Native macOS is awesome. But mainly, React Native in 2026 is just so good. The game has totally changed. The new architecture unlocks big possibilities. Hermes keeps getting better. Nitro modules are crazy fast. Lists are no longer a bottleneck. As we just saw, redraw makes incredible graphics easy and fast. Keyboard controller makes keyboard management super smooth. Agent Device and Argent have cut my debugging time down just so much. It's incredible. But still, React Native is seen as a compromise. And that's just not actually true. I've seen and worked on React Native apps that are fully best in class, sometimes better than native apps. I know it's possible. But this year, I've also looked at a lot of code bases for consulting work and helping companies with legend list issues. And I saw the same problems spread all over the place. So I want us to stop fixing these same symptoms over and over, and let's try to fix that root cause. Because React Native is not slow, the way we use it is. If you've seen one of my talks, you may know my catchphrase, render less, less often. But today I want to make it spicier, render once. But first, why is rendering too much a problem? Everyone talks about reducing renders, but what's the actual impact here? So I did a little benchmark in my music app to compare what if I re-render from the top app all the way down versus in a medium-sized component in the middle down to the bottom, or I just re-render a tiny text element leaf node at the bottom. When that render passes all the way down from the top, it has to do a lot more work along the way. rather than just updating one text element. But it's got to be a small difference, right? No, it's huge. Even I was surprised by this one. Moving the update target from the top-level app down to the tiniest leaf node made a huge difference. It reduced the CPU usage by 10 times. So rendering less has a really deep impact. But React's state model is designed around re-rendering. Render coordinates everything. Render passes local state down the tree. It updates context consumers. It triggers effects. It updates query properties. It updates external properties. It updates subscriptions. And it also updates UI. That's a lot of responsibility for what we call render. And that's where so many normal React patterns become a big performance problem. So let's say we're making a chat app. We have a reply feature that changes the color of a message. That's cool. Re-render the message to update the color. And then you want to also show in the composer that you're replying. So now we need to access the same state in sibling components. So what do? Say it with me. You lift state up. All right, nobody did it. Well, you do what the React docs tell you to do. You lift state up. As the docs say, it's one of the most common things you'll do writing React code. So you move the state up to the top of the tree, and you pass it all the way down. And it re-renders every component all the way down. It re-renders the chat screen. It re-renders the composer with all of its dialogues and buttons and hooks. It re-renders everything down to the message list. And then it re-renders every single chat message. All that one message can change a background color. And this is just killing performance. Now, React compiler helps a lot, and you should absolutely use it, but it can't save you from actual changes. When prop is changed, it has to pass the state all the way down. Compiler can't help this. So to update a style in one message, we have to cascade state changes through the whole screen. And let's talk about effects. Here's an example from the React docs, controlling a modal dialog. To open a modal on button press, we could just open the modal imperatively, but the React pattern is to set state, which triggers a render, then use an effect to open the modal. It doesn't actually change what renders, but it re-renders anyway. Or maybe I want to pause query polling temporarily. I have to set a state so that I can call the useQuery hook again with different parameters. Setting is paused doesn't actually change what renders, but we have to re-render anyway to update the query. Or I want to mark a chat as read, but only when the window is focused. The usedIsFocused hook re-renders when focus state changes, so we have to run it in an effect. That doesn't change what renders, but now this screen re-renders every time focus changes. This is all because render is needed for coordinating things that aren't even rendering. We're wasting all of this computing to just run side effects and move state around. Now let's talk about callbacks. Shout out if you see the problem here. All right, nobody did it. Well, the depths array needs to have a value in it, or this callback will become stale when value changes, and then we'll log a value. We'll log the old value. So you add value to the depths array, and it's fixed. But now onPress changes whenever value changes, and that means this big component also re-renders whenever value changes. You can't easily see this by looking at it. It's a hidden performance problem. I've seen tons of mistakes like this, causing noticeable freezes when some spaghetti path of a state change accidentally re-renders the whole app. This kind of silly mistake can actually have a really deep impact. And finally, let's talk about state. React state is extremely blunt and oversubscribed. UseState doesn't just create state. It also subscribes the current component to that state. That sounds normal, because we're all used to it by now, but it's actually a huge limitation. The owner of the state has to re-render when it changes, and then it's responsible for passing it down to whatever uses it. Ownership and subscription are tied together. Context can be even worse. UseContext doesn't only subscribe to the field you need, it subscribes to the whole context value. Whenever anything in the context value changes, all subscribers re-render. Say you want to get font scale in your custom text element. This will re-render every text element whenever font scale changes. That's not great, but it doesn't happen too often. But that's a trick. You actually subscribe to the window size too. So when a tablet or desktop user resizes the window, every single text element across your whole app re-renders, and your app freezes. It doesn't actually need the width here, but use context subscribe to it anyway. So now you have a huge performance problem for no reason. So we know that rendering too much, too often, is a major cause of performance problems. But render is the orchestrator of everything. And React encourages re-rendering often and spreading those renders deep and wide. So that's the model that I want to break. Instead of re-rendering everything everywhere all at once, we render just once. We don't even need to change the framework to do this. We just have to think about state differently and coordinate state separately from render. Currently, render coordinates everything, and state owners push the state down. Instead, let's let consumers update themselves as needed. And all we need for that is stable state objects that you can subscribe to. Some people call these signals, some call them observables. Reanimated calls them shared values. The key thing here is that useObservable does not subscribe to the state. It just creates it. Any other component can useValue it to subscribe to it. This separates the ownership from the subscription. We lift the state ownership up when we need to, but we push state subscription all the way down. So in this example, the chat screen passes these stable state objects that never change, so it never has to re-render. Then this tiny little reply row subscribes to the state that it needs, and it re-renders itself whenever it needs to. It does almost nothing, so the cost of re-rendering that is tiny compared to re-rendering the whole chat screen. So whereas normally the whole app would re-render because the state is owned and subscribed at the top, with this setup, only the affected components re-render. Nothing else is visually changing, so they don't need to re-render, so we can just skip all of it. If a callback needs a state value, it can just get the value. It doesn't need to pass through a render. It doesn't need to be constantly recreated. It can just be a stable function that never changes. An observing effect can just rerun itself when the state it cares about changes. It doesn't need a render to update it. It automatically subscribes to any state it accesses. So we can open a modal without any render coordination and still have the state to track it. Use context is still very useful, but to provide stable state objects. That way the provider never re-renders, and the consumers can select which specific thing to listen to re-render as little as possible. We could also subscribe to derived values. So rather than subscribing to reply ID, which would re-render every single message, it can subscribe to a derived value so that only one reply message actually re-renders. So when I say render once, I don't mean never update. I mean render the app and large coordinating screens once. Let leaf nodes re-render themselves. Let effects rerun themselves. Don't orchestrate through render. This way your apps just do a lot less work. And this is not just a wild theory I have. I've actually been building all of my apps and libraries like this for 10 years. If you use my state library, Legend State, you probably realized a while ago I've just been describing how it works. And this is basically how other frameworks like Solid, Svelte, and Preact work. But it's actually already in React Native. This is how Reanimated works. A shared value is a stable state object. When you get a shared value within an observing hook, it subscribes and updates itself automatically. You can set it anywhere in your code, and it'll update the UI without a render. So we're actually already doing this to get the best performance with animations. And if you use Legend List, you also have this pattern in your app already. This is the main reason Legend List is the fastest list library on mobile and web. It just does less work. It uses less CPU. Legend List mounts a pool of absolutely positioned containers up front, and then it never re-renders that array ever again. It signals individual containers to re-render themselves when needed. So when you scroll down, it signals one container to re-render at a new position with a new item. This keeps the size of renders as small as possible for best scrolling performance. When an item's size changes, which happens quite often, a tiny wrapper component re-renders itself with just a style change and nothing else. When the list size changes, it skips rendering entirely and it updates an animated style. It's not actually animating, but it's more performant than doing a render. These size changes happen very often while you're scrolling as new items come in and you have an estimated size and an actual size. They lay out, you measure. So this happens a lot. It would kill performance if it had to update and render the outer list component with a new size every single time. Legend list is fast because it's extremely careful to do less work. Rendering has a real and significant cost. So for the fastest possible apps, render less often. Or pushed further, render once. Use React to create the structure, then update the smallest leaf nodes directly. But this isn't just a list hack. This is the model I want you to take back to your apps. So try this today. Well, maybe not today, since we're at a conference. So try this on Monday. The first step is to find what's actually slow. Look at your slowest screens and interactions. Just throw logs everywhere and just see what's rendering so much. Or use the highlight updates feature in the dev tools to just watch renders as they happen, figure out what's going on. Then just try optimizing that screen to see what you can do. This problem can actually be fully solved with a state library. It doesn't need any framework changes. Obviously, I recommend Legend State. I'm not aware of any other state libraries that do all of this, but there are some other signal style libraries that you can use if you prefer, or just make your own. The key thing is you want to decouple the state creation and subscription, and push the renders down as far as you can to the leaf nodes. I know this is controversial. Everyone has very strong opinions about state. I've gotten a ton of pushback that teams don't want to change their state libraries, or they prefer to just use the built-in state and use context, because that's what React recommends, right? But you already use reanimated instead of the built-in animated because it's better. You dropped style sheet for unistyles or native wind or uniwind. If you still have flat lists in your app somehow, talk to me after this. I hope you're still not using touchable opacity. So why are we still clinging on to the built-in state? Some teams just refuse to use the state library, or you're a library developer and you don't want another dependency. I understand that. So there's also some lower level things you can do to cut out the renders. So instead of this very familiar pattern, try to use the imperative APIs rather than hooks to avoid the re-renders. So instead of re-rendering every time window size changes, you can just get the window size when you need it. And then you can subscribe to it. Missed one. So you can subscribe to it changing and then do whatever you want with it. If you want to pass that through state, cool. If you want to send it to post-hog or whatever, that's fine. And if you're a library author, please add an imperative API as well as a hook like Dimensions has. So then you can get the value when you need it. You can use an event listener to hook into it if you want to. You don't need to do a re-render for it. Another pattern I've used is to make hooks take a callback function and return a ref. So then the users can use the ref when they need to get the value. They can pass the ref around. It's a stable object. Or they can just listen to changes with the callback and do whatever they want with it. You can change your callbacks to something like use latest callback or use event callback, which updates them without dependency arrays. And that makes the callbacks stable, so they don't cause render cascades down the tree. If you really want to stick with context for some reason, but just not have the terrible performance problems that come with it, you could use something like use context selector. It still re-renders on every change, but at least it lets you select only the small piece you care about. But these are mostly small fixes to the symptoms. The deepest impact we can get is from rethinking state at a higher level. High-level orchestrating components should never re-render. They should own the state but not subscribe to it. Re-renders should be pushed down to the leaf nodes. I know this is a departure from normal React patterns, but in my experience, it really does make apps a lot faster, and I think it's worth a try. I really believe state architecture is by far the biggest hidden bottleneck in most apps, so you should really care about it and optimize the bananas out of it. And I care so much about this, I built a whole state and sync library because it was the only way to get the best performance. This architecture, in my opinion, is how you get from fast for React Native to really fast. Render once. Thank you.